Right, question 2. So we've got this Harvard swimming pool here, okay, and detailed shape here. And then we've got here, it says the pool is 1 meter deep at the shallow end, dropping to 3 meters deep at the other end. So I'm going to draw things, write things on my diagram. So we know that's 1 meter deep there, okay, and we know then at the deep end it's 3 meters deep. The width of the pool is 10 meters and the length is 20 meters. So when we're talking about the width, that would be the width there, okay. It's just like the top of the pool looking down on it. So the width is 10 meters and it says the length is 20 meters, okay. It says then the length of the sloping pool floor of the pool is 20.1. So we're looking at the bottom sort of the pool there, that length there is 20.1 meters, okay. The 4 walls and the floor within the pool are to be covered in tiles, okay, which is normal for a swimming pool, isn't it? This cost will be £20 per metre squared, okay. The labour cost of fixing the tiles is £150 per day, and it should take 6 days to tile the pool. Calculate how much it will cost the hotel to tile the swimming pool. So we've got obviously labour costs to pay for the work people to put the tiles in for 6 days they'll be working for. But let's focus first of all on the walls, okay. We need to, if you think about it, we need to work out the area, don't we? We need to work out the surface area of all of the walls, okay, because that's where the tiles are going to go. So the 4 walls, so if we look at the 4 walls, let's look at this end first, okay. So we look at the area of the walls to start with, okay. Well, this one here, this sort of width here, as it was called, is 10, yeah, and the height at this shallow end is 1, so it'll be 10 times 1. Right, that's the rectangle there. The deep end then, we know that the width is 10 and the deep end then, the height is 3, so 10 times 3. Alright, and then if we look at the other walls, the ones that are facing us here, of course we've got to think about what shape this is. And actually that's the shape of a trapezium, isn't it, if you think about it. If I turn it around, you could see quite clearly there it's a trapezium, and these 2 sides are the parallel sides. Okay, they are the parallel sides there in the trapezium. You have 1 pair of parallel sides as the trapezium. So for that then you're going to need to use a formula, okay, and the formula is in the formula booklet, of course. So it's half, let me write it here just to remind you, half A plus B times H. So it's on page 2 on the formula page that you get for this paper. Half A plus B H. So your A and your B are the sides that are parallel, okay. So your A in this case is this side, which would be 1, and then the B then would be the other parallel side, which is 3, and then you've got to times it then by the height between them. Now when you do the height, remember it is not the sloping bit here, the height has got to be this here, it's got to be the one that's at right angles to it for the height of a trapezium, so that would be 20, okay. And then you've got to add on then the other trapezium on the other end. But of course, you know, I'm starting to write this here, but you should realise that the other end is going to be identical, isn't it? So there's no harm in writing it out like that again, but it is going to be exactly the same. So if we work these out, that would be 10, that would be 30, okay. This then, let's take our time on this. Let's do the bracket first. 1 plus 3 is 4, okay. Half it then is going to be 2, and times it by 20 is going to be 40, and then that's going to be 40 as well. So we get our answer then, that's 40, 80, 120 meters squared, okay. And then the floor, okay, so we've done all the walls, we need to do the floor now. So the area of the floor. Now, when we look at the floor, it is actually a rectangle, right? Even though it's sort of on a slope here, if you think about it, it is a rectangle where the length is 20.1, and then the width then is this here, which is the width of the pool, isn't it? Which is 10. So it'll be 20.1 times 10, and of course, when you times by 10, it gets 10 times bigger. So the digits move 1 place to the left, so you get 201 meters squared. All right. So add these together. Right? Add these together, so you get total area, be those two added together, 120 plus 201, which will be 321 meters squared. Okay, so that's how much surface that needs covering there with the tiles. Then it goes on to say, look, the cost of each tile will be £20 per meter squared. So every meter squared there is going to be £20. So we're going to need now, if you think about it, we're going to need to multiply 321 by 20. Okay, so the cost for tiles and everything that comes with it, all the materials and so on, will be £20 per square meter. So it'll be this 321 square meters, so it'll be 321 times 20. Now when you times by 20, it's really easy, right? You could just times by 2 and add a 0. That's one way of thinking about it. So 321 obviously times 2 is 642, and add the 0 on. This is essentially what we're doing here is we're timesing it by 2 to start with, and then timesing it by 10. That's what we're doing. We're splitting 20 up into 2 times 10. So if you do that, you get 321 times 2 is 642, and then add on the 0. So that's the cost there for the tiles. We're not quite done, aren't we? Because we've got to pay for the workmen as well, and there's 6 days, and they're charging £150 per day. So cost for labour will be £150 times 6, okay? And if you do that, well, 15 times 6 is actually 90. Okay, 15 times 6 is 90, but then add the 0 on, so it's 900. So total cost then will be 6,420 plus the 900, and if you work that out, it becomes 7,320.